What if the battery was no longer the weak link? No degradation after a few years. No anxiety about charging cycles. No countdown timer quietly ticking toward replacement. What if a battery could survive 100,000 charge cycles and still perform? That's the promise coming out of a small but ambitious company called Donut Lab, a solid-state battery, radial design, extreme power density, and a lifespan that, if true, would rewrite the rules of energy storage. But extraordinary claims don't just invite excitement, they demand scrutiny, because in battery science, the difference between possible and proven is where reality lives. Tonight, we're not here to tear anything down. We're here to slow the story down, strip away the hype, and ask a harder question. What would it actually take for a 100,000 cycle solid-state battery to be real? Section 1. Why this claim is so disruptive. To understand why Donut Lab's claim is so explosive, you first have to understand how batteries normally die. Lithium-ion batteries, the kind in your phone, laptop, and EV, don't fail all at once. They fade. Every charge and discharge slightly damages the internal chemistry. Electrodes expand and contract, microcracks form, electrolytes break down. Lithium becomes trapped and unusable. Most consumer batteries are rated for 500 to 1,500 cycles. High-end EV batteries might reach 3,000 cycles with careful management. Some lab-grade lithium titanate cells can exceed 10,000 cycles, but at the cost of energy density so low they're impractical for most vehicles. Now compare that to Donut Lab's number 100,000 cycles. That's not a small improvement. That's 1 to 2 orders of magnitude beyond anything in mass production today. At 1 cycle per day, that's 273 years of operation. Even at 10 cycles per day, nearly 3 decades. So either Donut Lab has discovered something fundamentally new, or the definition of cycle is doing a lot of work. Section 2. What Donut Lab is actually claiming. Here's where many discussions go wrong. Donut Lab is not claiming a phone battery that lasts forever, a miracle material that breaks physics, infinite energy density. What they are claiming is more specific and more subtle. They describe a solid-state battery with a radial donut-shaped architecture designed for extreme power throughput and tested for up to 100,000 partial charge cycles. That last word matters. Partial cycles. In battery science, a cycle is not always 0% to 100%. A battery cycled between 45% and 55% or 20% and 80% experiences far less stress than a full depth of discharge cycle. So the first reality check is this. 100,000 cycles does not automatically mean 100,000 full cycles. That doesn't make the claim dishonest, but it does mean the headline number requires context. And context is where truth usually lives. SECTION. 3 solid-state batteries. The real advantages. Solid-state batteries aren't magic, but they do solve real problems. Traditional lithium-ion batteries use liquid electrolytes. Flammable, chemically unstable, prone to forming dendrites, metallic spikes that cause failure. Solid-state designs replace that liquid with ceramics, polymers, or hybrid solid materials. This change alone can improve safety, reduce unwanted side reactions, dramatically slow long-term degradation. In theory, a well-designed solid-state battery can last far longer than lithium-ion, but far longer usually means 2 by 5x, maybe 10x, not 100x. So Donut Lab's claim isn't just about solid-state chemistry, it's about architecture. Section 4. The donut shape is not a gimmick at first glance. The donut shape looks like branding, but from an engineering standpoint, it's actually the most interesting part. Traditional batteries are stacked. Layers of anode, electrolyte, cathode. This creates uneven current density. Hotspots, mechanical stress at edges. Donut Lab's radial design changes the game. Current flows evenly outward over shorter distances with dramatically reduced resistance. Lower resistance means less heat, less mechanical stress, less chemical breakdown per cycle. In high-power applications like motors embedded directly in wheels, this matters enormously. So here's the first place Donut Lab's claim gains credibility. They're not just changing chemistry, they're changing geometry. That alone could plausibly extend cycle life, especially under partial cycling. Section 5. WHY high power can mean long life. Counterintuitively, here's something most people miss. Batteries don't just degrade from use. They degrade from inefficient use. Heat is the enemy. Voltage spikes are the enemy. Localized current overload is the enemy. If a battery is designed to deliver extremely high power with minimal internal resistance, then operating it below its maximum capability can be surprisingly gentle. It's like driving a sports car at city speeds. Donut Lab's batteries appear designed for short bursts, high currents, rapid charge and discharge if tested under controlled, shallow cycling conditions. Reaching tens of thousands of cycles becomes not impossible, not proven but plausible. Section 6. Where the claim becomes fragile. Now we get to the uncomfortable part. Because even if everything so far is true, scaling changes everything. Lab tests are not the real world. In the real world, manufacturing defects accumulate, temperature varies, vibration causes microfractures, charging behavior is unpredictable. A single ceramic microcrack can increase resistance, create localized heating. accelerate failure dramatically, and solid-state batteries, especially ceramic-based ones, are notoriously fragile at scale. So the real question isn't, can a solid-state cell survive 100,000 cycles in a lab? The real question is, can thousands of them survive real-world abuse consistently? That's the gap between prototype and product. Section 7. The most likely interpretation, the realistic one. So let's strip the drama away and be honest. The most realistic interpretation of Donut Lab's claim is this.